Now let's talk about doing some math with these polynomials or these monomials and see what that means for us. First of all, let's look at multiplication and how we multiply. We looked at how we add and subtract, but let's see how multiplication changes things. I put some notes at the top of this page that you might want to refer back to, especially when you get around to multiplying two binomials together. You'll remember these directions for FOILing it. If you need that method, then you can go back here to it. But I want to go straight to example 1. This is basically a monomial times a binomial. So I'm going to distribute this multiplication 2 times. I'm going to multiply negative 4xy times 9x, and then I'm going to multiply it times y. So I'm going to do it one step at a time. I'm going to say negative 4 times 9, work with the coefficients first. Negative 4 times 9, well, that's a negative 36. And then I multiply like variables, x times x. Well, that gives me x squared. And there's nothing to multiply the y times, so we say y times 1, and that's just y. So I've taken care of this first term. Now let's multiply it times the second one. I'm going to distribute it by multiplying this negative 4 times this positive 1 that's in front, and I'll get a negative 4. And then x has nothing to be multiplied times, so it's simply multiplied times 1, and y times y gives me y squared. So I've basically distributed the multiplication a monomial times a binomial. Remember, these polynomials, the terms are separated with either addition or subtraction. Now the next one has a binomial times a trinomial, so it becomes a little more complicated. I'm going to multiply each of these 2 terms times each of these 3 terms. Now you can think of it like this. In the first example, I multiplied 1 term times 2 terms. I had to do 1 times 2. I had to do 2 multiplications, 1, 2. And this time I'm going to be 2 terms times 3 terms. Well, 2 times 3 gives me 6. I'm going to be doing multiplication 6 times. Then I'm going to be combining like terms. When I did the first one, I had no like terms to combine. X squared y is not the same as xy squared, is it? But let's see what happens with this one. I'll take 8x and multiply it times the first term, the second one, and the third one in the trinomial. So I'm going to say 8x times x cubed. Well, 8 times 1 is 8. X times x cubed gives me x to the 4th. Now let's do the second term. 8x times negative x. Well, 8 times negative 1 is negative 8. And I say x times x is going to be x squared. Next, the third term, 8x times a positive 5. Well, 8 times 5 is a positive 40. And x times nothing, or times 1, really, is x. So I've done the first one. Now let's take the negative 8 and distribute it. Negative 8 times x cubed, that's going to give me negative 8 x cubed. Negative 8 times negative x, well, that's a negative times a negative, so I know it's positive. And it's 8 times x, which is going to be 8x. And then it's negative 8 times positive 5. Well, that's a negative times a positive, so it's going to be a negative 40. And there are no variables, so it's just negative 40. Now let's look at like terms and see what we can combine. Well, I've got x to the 4th, and then I've got x squared, x cubed, x. I don't have many like terms. In fact, as I see it, I've only got these 2 that need combining, 40x and 8x. And that's going to give me 48x, but I think I can go ahead and write the rest of them down and just do it as one step. The highest degree is the one with the highest exponent. I write it first. So it is 8x to the 4th. Let's look for the next highest exponent. I'm going to check it off because this can get confusing. And it's right here, the cubed. So I'll say negative 8x cubed would be next. Got rid of that one. What's next? Well, let's look for this one that's squared. Negative 8x squared. And then finally I come down to my x terms. So I have 2 of them. So I'll combine them. 40x plus 8x is going to be a positive 48x. And finally, the term that has no variable. I've combined all of my terms. I've written them from highest degree to lowest degree. And you can see there's no like terms we did. We did the distribution and combining the like terms and had nothing left. Okay, next, a binomial times a binomial. These are the notes that I left for you up here. Foiling them is what we usually think of when we're doing binomial times binomial. What we do is we take the first term in each binomial and we multiply those together. I'm going to write the letters for FOIL right out here so we can kind of do it as we see what I'm doing as I go. When I multiply x times x, I get x squared. Now I'm going to do the O in FOIL. I'm going to do the outside terms. That's x times negative 7. So I'm really going to say x times negative 7, negative 7x. Next is the I, which is the inside terms, the ones closest to each other. Positive 9, positive x, that's going to be a positive 9x. Remember to watch the signs. And finally, the last terms. The last term in each binomial, 9 times negative 7, it's going to give me a negative 63. Now, when you FOIL, the advantage is the like terms, if you have any, are going to be right here in the middle together. So I've got x squared, and then I can combine negative 7x, positive 9x, I'll get a positive 2x, and the rest of them I can just bring down. I end up with a trinomial, which is the most common scenario when you FOIL two binomials. You multiply two binomials together. Let's look at this second one. It's another FOIL example, binomial times binomial. So I'll start with the first terms. 2x times 8x, 16, x squared. Outside terms, 2x times negative y. Write the sign down first if you see it. Positive times negative, 2x times y, and you write your variables in alphabetical order. Next is the inside terms. I've got a negative times a positive, so that's going to be a negative. 3 times 8, 24. X times y would be another xy. And the last terms would be a negative times negative, which would give me a positive. 3 times 1, y times y. That looks right. Let's see if we can combine these two like terms that are in the middle. We have 16x squared. Negative 2 minus 24, both of them are xy terms. I got negative 26 xy's. And I've got a positive 3y squared. Next, another FOIL problem. 2x for the first terms, 2x times x is going to give me 2x squared. Outside terms, 2x times negative 6, negative, and it would be 2 times 6, right? 12, and I have to remember there's an x there. Inside terms, it's going to be 1 times x. Both of them are positive. So it's really just going to be plus x. And last terms, it's my last part. 1 times negative 6 is going to be a negative 6. Now, these are like terms. If you're confused, just put a coefficient of 1 in front of that plain old x, and you'll see that you're really going to be saying negative 12 plus 1, which is going to give you a negative 11x. And the rest of them I can just bring down because there are no like terms to combine. Problem number 6 is really a FOIL problem, but it's written as binomial squared. What you have to remember is that you cannot square each individual term of the binomial. What you must do is rewrite it. X plus 6 times x plus 6. And don't forget that, because that is a common mistake. So let's FOIL. X times x is x squared, first terms. Outside terms, x times 6 is a positive 6x. In fact, all of these are going to be positive, right? No negatives anywhere. So we don't really have to worry too much about signs. Inside terms, 6 times x, another positive 6x. And last, we're going to get 6 times 6 for a positive 36. We're going to combine these two inside terms that match, and we'll say 6x plus 6x is 12x, and we'll add 36. There's a pattern to this one that you should notice, okay? I want you to just jot a note here that this one has a pattern. The pattern is, if I have a binomial and it's squared, I can square the first term. Here it is. I squared the first term. I can square the second term. Here it is, squared. Then I have to multiply these terms together. 6 times x would give me 6x, and double it. 6x times 2 would give me 12x. And that's the pattern to a binomial squared. course, foiling always works. So if you forget that pattern, go ahead and FOIL it. Now, let's look at something called perfect square trinomials. They're squares of binomials. They're going to be called perfect square trinomials, and they're going to always kind of turn out a certain way. We want to get used to seeing these patterns because we want to be able to go backwards when we get around to factoring, and we reverse the process. So it's kind of nice to be able to see it while we're multiplying binomials or polynomials together. Here's another one. This one, we can also do the same thing I did before. I could say, this is really 2x minus 3y times 2x minus 3y. Now, if I look at the pattern and I say, well, this is really, I really could just square the first term, and that would give me, I'll come over here and do it, that would give me 2x times 2x, wouldn't it? Which would be 4x squared. I could square that last term, negative times negative. Negative 3y times negative 3y, I'm going to have a positive 9y squared. And then I'd multiply these two terms together. Well, it's a negative times a positive, isn't it? So it's going to be a negative 6xy, and I would have to double that. So I would now have a negative 12xy. There's my answer, if I know the pattern, okay? Let's say I don't know the pattern or I don't remember the pattern. Then I go to FOIL. And for FOIL, I say the first terms together, 2x times 2x, gives me 4x squared. The outside terms are going to be 2x times negative 3y, which is going to give me a negative 6xy. Inside terms, negative 2y times 2x is another negative 6xy. Remember, write the variables in alphabetical order because xy is the same as yx. But if you write it alphabetically, you won't get confused. And then the last terms are going to be a negative times a negative. It's going to be a positive, 3 times 3, and y times y. Combining these middle two terms, I end up with 4x squared minus 12xy plus 9y squared. But if I see the pattern, I can go directly there. All right, let's try the pattern on this one. Let's say I want to say, okay, this is 2x, and I would square it, right? Plus 2 times, and what would I multiply? 2x times 3y. Multiply the terms together, and then I'm going to say plus, and I'll have that last term, which is 3y squared. That is the pattern written out for you. How do you square 2x? 2x times 2x, 4x squared. Don't forget, you got to square the coefficient too, don't you? Plus, I'm going to go in here and say this is 2x times 3y gives me a 6xy times 2 gives me a 12xy. And down here, I'm going to say 3 times 3 is 9. Y times y is y squared. So I've done this one several different ways so you can see it with the pattern and you can see it without the pattern. Let's look at another one. This time, these binomials that we're multiplying together look exactly the same, except for one thing. You should note that the operation in between, the operation in the middle of the terms is not the same. This is plus, this is minus. This is another pattern that we need to be aware of. It's called a difference of two squares pattern, okay? It's going to turn out to be a difference of two squares. We call it DOS, or difference of two squares, and I've written it for you, some notes for you at the top. So how do we really figure this one out? Well, we'll FOIL it, and then you'll see the pattern that emerges after we do that. We'll multiply the first terms together. 3 times 3 is 9. A times A is A squared. B times B is B squared. That's that. Outside terms, well, this is going to be 3 times negative 4. It's going to give me a negative 12. A times 1, B times 1, and C times 1, because they didn't have a matching variable in the other term, did they? Next, inside terms. 4 times 3 is a positive 12. And once again, I'm saying A times 1, B times 1, C times 1, because there's no matching variable in the other term. And last, I'm going to say negative times positive. That's going to give me a negative. 4 times 4 is 16. C times C is C squared. And look what happens when you have this situation. identical terms in the two binomials, opposite signs in between them. The middle two terms, the inside and outside, are going to be identical opposites. In other words, they're going to add to 0. So all you're really going to have is the first term squared, and you're going to subtract the second term squared. And that is a difference of two perfect squares. If it's a pattern that you see, fine. If it's not, then just remember this is going to happen when you FOIL it. Next, I'm going to look at a trinomial that is squared. And there's no real easy way to do this one. This is a lot of multiplication. We're multiplying 3 terms times 3 terms, so we're going to have to multiply 9 times and then combine like terms. So the only way to do this is to write it out. So I'm writing out my trinomial times my trinomial. And now I'm going to start distributing multiplication. But because I know I'm going to do 9, I'm going to multiply each of these times each of these. I'm going to multiply 9 different times here. I'm going to kind of stack these over like terms so that I can add them up on top of each other. So when I see something that's alike, I'm going to put it under something else that matches matching terms so I can add easily or combine easily. This was the first one. 3x squared times 3x squared is going to give me, here I go over here, 9, and x squared times x squared, x to the 4th. Next, I multiply, that's 3x squared times 2x. 3 times 2, positive 6. Look, there's no negatives, so I'm going to go with positives in between all of them, which is easier. X squared times x, x cubed. And then I've got 3x squared times 4. 3 times 4 is 12. Add x squared times 1. Okay, so I've got an x to the 4th, x cubed, and an x squared termed. If any of these others turn out to be the same, I'm going to stack them on top of each other so they're easy to combine. The next thing I have to do is multiply the second term times each of the 3 terms in the second polynomial. So I say 2x times 3x squared. That's going to give me x cubed. I have an x cubed, so I'll write it under here. This is my x cubed term, and it's 2 times 3, so it's 6. I'll put a plus because I'm going to add those. And the next one is going to be 2x times 2x. Well, that's going to give me x squared. I already have an x squared term, so I'll put it here. And it's really going to be 4x squared. I'll put a plus there. The next one is going to be 2x times 4. That's just going to be a plain x term, which I don't have, so it'll come down here at the end. It's going to be just an x term. 2 times 4 is 8. It's going to be a positive 8x. Now, let's take the last part, the last term in our trinomial, multiply it times each of the 3 in the second trinomial. It's hard to draw these lines. Let's do it like this. 4 times 3x squared. Well, this will be an x squared term. I'll put it under here. 4 times 3 is 12. Once again, it's positive, so there it is. The next one is going to be 4 times 2x. That's going to be a plain x term also. 4 times 2 is 8, and it's a positive 8. And the final one is just 4 times 4, no variable. We can put it down here at the end. 4 times 4 is, of course, 16. Now, we got to combine all these terms, but we made it easier on ourselves because we stacked like terms together, so we don't have to go searching through one big long line to find them. And I can just come over here and say, okay, 16, nothing to add to it. 8x plus 8x is 16x. And then I've got 12 plus 4 plus 12. Well, 12 plus 12 is 24, plus 4 is 28. Those are my x squares. And then I've got 6 plus 6, x cubed, so I have 12 of those. And nothing to combine with the 9x to the 4th. Now check it out. From the highest degree down to the smallest degree, I've got it in order, and none of these terms are alike. So I have combined all like terms as I finished my multiplication.